Well, we're here in beautiful Melbourne on the traditional lands of the Wurundjeri people of the Kulin Nation. Right now, I'm in Royal Melbourne Hospital and I'm just outside of the specimen drop-off window of the Department of Anatomical Pathology. If you've ever had a biopsy removed or perhaps a part of your body removed as part of an operation, well, you might have wondered, where does that tissue go and why is it taken and why is it processed and looked at? Well, this video is about just that. Well, the process has already begun before the specimens arrive here in pathology, because usually the tissues have been put into a fixative solution like formalin to stop them from breaking down. Well, the specimens then come to this part of the laboratory where they're cut up and put into little cassettes for further processing. Now, during this stage, the pathologist is looking to see which parts of the specimen are going to be diagnostic, so they're very careful to pick the right bit of the specimen to put into the cassette. And also, they've often painted the outside of the specimen so that when they look at it under the microscope, they can see the painted margin. And that tells them whether or not any cancer that might be in the specimen might have been partly left behind in the patient. Now, further processing of the tissues is to transfer the cassettes with the specimens in them into one of these machines. And what these machines do is that they exchange water with alcohol, and then alcohol with xylene, and ultimately xylene with paraffin wax. And it's paraffin wax that is going to ultimately be hard enough to prepare tissue sections. Now, once the tissues have been infiltrated with wax, they're now ready for embedding, and what that means is that they're mounted in little moulds so that when the paraffin sets hard, the tissues are in a good orientation for sectioning. Well, now that the tissue is in a solid wax block, that block is transferred here to one of these machines. This is a microtome that's capable of cutting incredibly thin slices of wax with the tissue embedded in it. Now, those slices are amazingly thin. They're about 1/3 of the thickness of a red blood cell. And these are then transferred to glass slides, ready for the next step. Well, the sections that are produced are still essentially transparent, and also they're in wax, and if you look at them, they look terrible. You can't see anything. So that's where this machine comes in. What this machine does is that it removes the wax and replaces the wax ultimately with an aqueous solution, and then the section is stained with hematoxylin and eosin, a blue and a pink stain that produces these beautiful blue and pink slides. Now, that is something that you can look at under the microscope. Sometimes you'd actually like to know something about the actual chemistry of what's in the tissues, and that's where a whole bunch of special stains come in. This is the special staining part of the laboratory. Now, some special stains are just about getting stains to actually bind or react with chemical components in the tissues, but there are other special stains that actually detect the actual presence of actual enzyme activity in the tissues. So these can be enormously informative. Sometimes special stains aren't enough. On occasion, you might want to use antibodies that are directed against particular protein components of the tissues to identify whether or not a particular lesion is one particular type or another. And in fact, sometimes panels of antibodies are used to make a final diagnosis. Now, these antibodies bind and they're detected by using various enzyme systems that make a colour product in the histological section, but on other times they might be tagged with fluorescent probes that you can observe with a fluorescence microscope. But there are some occasions where even those approaches, those very powerful approaches, aren't enough. On some occasions, you need to just physically look at a higher magnification at the tissues, and that's where you need to have transmission electron microscopy. To look at this, we're going down to the pathology department in Royal Children's Hospital, Melbourne. Well, electron microscopy is in principle similar to light microscopy, except that everything's much, much smaller. The specimens are much smaller and the sections are much smaller. Even the microtome, Well, the microtome's not much smaller, but it's designed, it's even got a microscope attached to it so that you can see the sections as you're making them. And they come off onto not a glass slide, because a glass slide would get in the way of the electron beam that you're using to examine the specimen. Instead, the sections go onto little copper grids like this, and they are stained not with coloured agents like hematoxylin and niacin, but they're stained with heavy metals like osmium or lead or uranium traditionally. So it's a different type of image that you get with electron microscopy. It's a black and white image, but incredibly high magnification. Right, well, this is a transmission electron microscope. You can see it's much larger than a light microscope. Basically, it's a column, it's a tube, and it's kept under high vacuum because basically it's an electron beam. If there was any air, any gas at all inside of this tube, well, then the gas molecules would get in the way of the electron beam, and it just wouldn't work. So at the very top of the column, there's a source of electrons that is driven down through the column by a high voltage that's kept between the top and the bottom of the electron microscope. So electrons are being fired down from the top down towards the bottom of the electron microscope, and on the way it's being focused. This electron beam is being focused by magnetic lenses that are in the top part there, first of all through the specimen, which is held in place by a special little specimen holder that enters the electron microscope through this portal, through this hole. The electron beam then fires down through here. There are further magnetic lenses that focus the electron beam now onto a screen that you can either directly visualize by looking through this little portal, and you can also look at it at higher magnification through this little microscope that's mounted on here. Or alternatively, you can also visualize what's coming down at the bottom by the electrons being picked up by a detector at the very bottom of the microscope, and you can then see the image here on a computer screen. So look, this is an enormously powerful technology. It will reveal details at incredible magnifications, but you can also see how you can only look at a very small amount of tissue with a transmission electron microscope. You can't get an overview of the tissue at all. This is for looking at very fine details in very, very small specimens. So it has specific application in pathology, but it's only used in special circumstances. Now, back to pathology at Royal Melbourne Hospital. Now, sometimes in the middle of an operation, the surgeon needs to know something more about the lesion that they're working with. They might want to know, for example, for sure, if a tumour is benign or malignant. They can't be absolutely certain from the earlier observations that have been made. So in that situation, they sent a sample of the tissue down here to anatomical pathology, and rather than putting it through paraffin processing, which just takes so long, it takes a day or so to do, instead the tissue is frozen here in one of these little freezing machines behind me, and then it's put into here. This is a cryostat freezing microtome, which allows frozen sections to be prepared and looked at on glass sliders similar to paraffin sections, but now with a somewhat lower resolution that is possible with paraffin sectioning. The important thing is that the surgeon can have a result very, very quickly while the patient is still anaesthetized. Well, the scientists who do all of this really quite difficult technical work, they have a dedicated training program, 3 years of training, as well as then continuing education and further accreditation processes that they submit themselves to. And I do wish that you could just come here yourself and see the level of care and dedication that they exercise in doing this important work. Well, the slides are now finally ready to be examined by pathologists, and that will be under a microscope such as this perhaps, and a report will be written, and that will be written taking all the information that's available together. That will be taking into account the history of the patient that comes with the specimen, taking into account the macroscopic appearance of the specimen that was recorded during cut-up, Also considering any special stains and antibody labels, a diagnosis will be made, and also a sense of how aggressive the disease is, how far it has spread, at least as far as you can tell from under the microscope. And this is the key information that the clinician will then use to deliver the best possible care that they can for the patient. Now, we've been looking at sections and section pathology, but in fact there's another part of anatomical pathology which is called cytology. Now, in cytology, rather than looking at sections, what's actually being studied under the microscope are whole cells, and in fact whatever else happens to be in the tissue. And this might be collected with, for example, a brush or a loop, like in a pap smear, or alternatively it might be cells and tissues collected using a fine needle in a procedure called fine needle aspiration, where a needle is passed into tissues and then drawn out, and whatever is collected inside of the needle is expressed out onto a glass slide and smeared out. It also includes, for example, a blood smear, a drop of blood on a slide and then smeared out. All of those methods involve cytology. And so in cytology, you're not just looking at a slice through cells or tissues, you're looking through the full thickness of the cells, and that has to be interpreted slightly differently. It has the disadvantage that you don't have tissue architecture, but it has the enormous advantage that you don't have to remove a chunk of the patient to try and work out what's going on in a particular lesion. Now, there is a branch of scientists who specialise in cytology and who are involved in looking at these sections, and this is the cytology laboratory. And these cytologists have a particular training, a special training that's added on to the original scientific training to allow them to serve this important role. And this is working together with anatomical pathologists to come to final diagnoses. So the report's been written, but the microscope slides and the paraffin blocks with the specimens in them, they are not thrown out straight away. In fact, they're hung on to for many, many years later on. I believe that the standard is for a minimum of 20 years. Here at Royal Melbourne Hospital, they hold on them for up to 30 years. 30 years of slides being stored away in special repositories like this. And the reason is so that if need be, it's possible to always go back to the original slides and always go back to the original specimens, the original paraffin blocks, and look again. Do another stain. There might be a new test that you can try out. These blocks and these specimens are hung onto because they are important parts of the patient's history and important for potentially being able to inform future diagnoses and future management. So every large teaching hospital with a pathology department will usually have a bunch of registrars training into anatomical pathology here. Now, this is the registrar's room where registrars have a long and arduous training, 5 years, during which they have to pass through primary examinations and then ultimately final examinations in every area of anatomical pathology before they can be qualified as registered pathologists. It's usually stocked with a very good library that's used by everybody in the department. Well, I hope that's given you a sense of what happens in an anatomical pathology department. Clearly, there's a team of highly trained, highly skilled, deeply dedicated people who work tirelessly to make sure that the diagnosis that they give for anything that you might suffer with is correct, and also to make sure that your doctor is as best informed as possible to make sure that you get the best care that they can deliver. So look, I hope that you've found this interesting and informative. If you have, that's wonderful. Please do like and subscribe and share. And if you haven't, I'd like to thank you regardless for your attention.